Welcome everyone. I'm going to talk about Azure Durable Functions. And those of you who already have heard about it, does anyone heard about Durable Functions? Does anyone use it? Okay, not many people. But Azure Functions? Azure Functions, okay, more people. So they are really simple, and very intuitive. And we will see it in a moment for those who are not familiar with them. However, this simplicity of durable functions can give you an illusion that you understand deeply how it works, and that can lead to some poor performance and also confusion. And today we will actually see how they actually work, and probably it will save you some time in future if you will deal with them. We already talked about the serverless, what it is. Everyone knows that the serverless doesn't mean that we don't have servers. It's just an abstraction. We just don't deal with them. We don't bother with the servers. We don't update them, keep them running and scaling. And they also event-driven. If something happens, they just jump in, do some computing. If not resources used, we don't pay. It's very nice. When we talk specifically about Azure functions, there is a set of events that can trigger Azure functions, like HTTP request or time-based event, or something comes from Microsoft Graph. And then our piece of code can react on it, and not only react on it, but also change another part of our system. For example, it can set a push notification or create some record in DB. However, there are still some challenges when you architecture serverless application using Azure functions. For example, if we have one function that does some processing, and we want to fan out these results to other functions, there are no such triggers in Azure that would fire another function with our parameters. What we most likely end up doing is creating another HTTP trigger or put messages into queue, and other functions will react on the message in the queue. But what if we want to gather these results from the function and process them in another function simultaneously, altogether? What can we do with the existing triggers, which are like reduced? How we can achieve this is it's not trivial. The set of available triggers, most likely you end up managing a lot of queues and topics, storages, and writing some boilerplate code like crazy, but you don't like it. Yes, it's like, but luckily we have durable functions. Tadam! They could help this. What they do in essence, they simplify orchestration of the functions, serverless functions. So what it does, it just makes sure that all the functions play nicely together in synchronized way, and also workflow can be defined in code. It gives some benefits that you can see everything, the whole workflow in your source control, and you don't need to go to some dashboard in I don't know, like in AWS, for example, somewhere. So it's easier to understand what happens. And one of the key features, it's 100% reliable, so progress is not lost even if virtual machine is restarting, for example. So how it would solve this problem? So what we get now with durable extensions, we get two additional triggers. One is orchestration trigger, and another one is activity trigger. And all these functions now become activities. And there come another one, which is orchestrator. Now what will happen is that orchestrator will contact with all these functions, and so it will get the results of the first function, and then it will distribute it to the functions in the middle, get the results from them, and then send all the results to the function that is on the right side.
Sorry, you didn't tell that. May I interrupt you, or?
Sure, you can. Yeah, you can. Yeah.
So what about ordering? So maybe you want something before another result. So you call these functions.
Yeah. So well, the order here we want to call first. The first function is triggered. For example, it can be HTTP request or message in the queue or some other events that are supported. And then we want to do some processing, and then we want to distribute the results to send it to different functions, and they should simultaneously process them. Then we want to gather these results and process in another function. Mm-hmm. So there is a sequence, this flow, and this flow can be resolved by orchestrator. So now we can program this flow in orchestrator inside in one function. So we will call one function, then we gather the results. That's demo coding coming in, so I can just show you. But before we go into coding, I probably should tell you what we go into code. So the idea is to put Azure Durable Functions under the heavy load and see what are the constraints and how it can handle something, some really, some severe processing stuff like image processing. So, for example, what I did. Oh, spoilers. Okay. I have so on that side. Okay, so what I have here is increase the font. Look how. Oh.
Same on that. Just win.
Okay. What we will do, we just take this open source image processing stuff and try to put it in a serverless environment. What this project does,
it's a bit more complex than Hello World, I guess.
It's more complex than Hello World, but before we start, what this project does, it has, for example, we have an image with this guy. Come here. So when we want to remove them from here, from this picture. So we also have the markup that marks him. And what it will do, it will run an image processing algorithm that will just remove this guy. How does it do? So it processes this image in steps. We don't start processing with the huge original image. It's easier to downscale it a couple of times. And then we get so-called image pyramids. So we have an original image on the bottom, then on top of it there is a double size downscaled image, and etc. And then we can start processing it, applying some filters From the top one, you see that the quality of it, because the resolution is really low, it's downscaled a couple of times, and then it gets sharper and sharper because we go in another level of this image pyramid. Yes, and in the end, eventually it should be just a sharp, good image. Oh. Keep moving the mic. Okay, so what we going to do with the durable function, we're going to emulate this process, how we would build this image pyramid. So what I have here, I have sources of durable functions, but you don't need it. If you want to use the durable functions, just use a NuGet package. I use this one to show what issues we have with durable functions. So if it breaks in the original code. And so I'm not going to be boring with watch me code stuff. It's I have prepared already some code here. We can increase this. So what we have here, we have HTTP trigger. It gets an get request, and it injects here orchestration client. Later on, we kind of simulate the input. It should be, of course, in the request. In original request, it's just a container name in our blob storage and original image and the markup image. And then we start our orchestration client. It will start the orchestration session. There is a orchestrator function name and the input. And then we immediately return a status response. It's a really handy one because, yeah, I will show you later what does it mean. And let's take a look at the orchestrator function. Orchestrator function is now, it should take the input, but I just hard-coded these images. Suppose we have this pyramid already with the image names, and then we want to apply some, let's say, blur filter to each of the images. So we will call activity function asynchronously. So when all these activity functions will process their images, we will collect the results and return it. So,
stupid question.
Of course.
Why do we need separate functions here? Why not just have one function which does this directly?
Because this we emulate. We can suppose that this function does something really heavy, and you don't want to run it in one application for in one function. You want to distribute the load. So each function will pick up a part of this load, will process it, return the results. Then you can process it.
So it's running in parallel, right?
Yes, it will run it in parallel, completely different functions.
Automatically.
Automatically.
It returns immediately if accepted.
It will return, yes. It will return the results. We will collect them, and we can do further processing of these results here. Yes.
Yeah, I have a question, but it's less about serverless, but the image processing technique that you're utilizing. So in that image, you were extracting the person.
Mm-hmm.
There were also some text there, like Chinese
Yes.
or Japanese characters. Do the same libraries and techniques that you utilize here, would they be enough if you wanted to extract the text?
Remove the text, you mean? Like we do with the person, we also want to
Sort of do OCR.
OCR. No, what we saw here, it just was my side project. I just implemented this in painting stuff. So it's completely different algorithms. So that's how this orchestrator works. If we run it, it should start our local. Oops. And we don't have Azure Web Job storage in our settings, which is strange because we don't use storage here anywhere. Okay, let's just put it and make it happy. How to use it? Oh, that's handy. Okay. So I have here already settings file prepared with my storage account in it.
So you were ready.
Yes, I knew about it.
That's one of the parts of the talk, isn't it? The problems you ran into.
Yeah. So yeah, it's here. Oh. Everyone's alive. Yeah. It takes long. Strange.
Are you sure it's not using any kind of storage? For example, where does the workflow orchestrator store any state when it's processing the workflow?
Oh.
Yeah, you're right.
Oh. Spoilers.
We knew all along.
Where is it? Oh no, it's the wrong one. Okay. Now it works, as you see. So if we will follow this URL, it will trigger our function. And this is the result of this check status response that it returns. So we already can see the status. We can terminate the process if it's taken too long. So if we check the status, it says that it's completed. We can see what was the input and what is the output. So it's the output that we collected from 3 different functions. They did this processing and return something. Okay, so that's part of this simple coding that demonstrates how durable functions work. So it's one of the samples that goes by default, and Microsoft usually shows this sample. Then it works exactly. Yeah, that's one of the CEO is reading. And yes, but it feels natural. It feels like usual coding experience. You just write this flow in your code. You call these functions as a different methods of any other class. So, and this simplicity can just you can extrapolate your previous experiences to these new circumstances and think that, okay, now I know how it works. I just call this activity like this and like that, and then you want to apply this in your project and something. What can go wrong? And yes, let's see. So what we will do now, we will take a bitmap from a blob storage. We will determine how many times we can downscale it to build this image pyramid, basically. We will simulate this. We will downscale it and apply some filters. And again, we are not going to see how I will write the code. We will just jump into some of the results. So the HTTP trigger stays as it was. Now what's changed is the orchestrator function. What happens in orchestrator function? Actually now it takes the inputs from the request, then we load a bitmap from our blob storage, then we prepare the collection for the results, to store the results, then we call an activity function that will calculate how many times we can downscale the image to build the pyramid. Then there is some methods to determine whether it needs cropping. Sometimes images needs cropping to be downscaled without distortions. And if it's needed, we will call another activity function which will crop the image. And then for each level, we will downscale the image, apply the blur filtering, and put the results. We will save in the blob storage and put the results to our collection. Yes, so looks fine. Let's run. Why? Yes, because the previous one is still running. Yes. That was not planned. Okay, now it's running. Let's trigger it. Something happens. Let's check the status. Here, running. Okay. Still running. And still running. So, but let's not wait because it hangs here. It will run like for hours and it never progresses. And what is really confusing about it that they don't throw any exceptions. They don't say that something goes wrong. So what goes wrong? If we take a look at this orchestrating function, we see that we call asynchronously one activity, another activity, another activity, and here we asynchronously try to load a bitmap from the storage, but we don't call an activity here. And that's what gives us problems here. So we just use not asynchronous version of loading from the blob storage, and it will work. So we can await and run asynchronously only activity functions. Strange. Let's check. So we call this, we check the status, and it's failed. Okay, but at least it doesn't hang. Why it hangs? Okay, it says that, oh, it cannot use the bitmap. Okay, why? Because it's not, it looks like this code is executed in one address space, but it's not, because it's serverless functions. So we cannot just pass this bitmap as kind of pointer to the function. We need to serialize it. Okay, so we have something like serializable wrapper for this bitmap. We wrap the bitmap, we pass it there, and we get the result. Okay, maybe now. Sorry? Oh, again. Am I on time? Yes, thank you very much. Okay, let's trigger it again. And it's failed. And why it's failed? Okay, I know why it's failed. No surprise. Now, though it didn't provide a clear message why it failed, but it failed because of non-deterministic behavior here. Usually, yeah, and maybe in previous versions, or maybe there's something happens still in this branch. What they usually say, like non-deterministic behavior detected and stop working. So orchestrator function requires deterministic behavior, and we don't have deterministic behavior here, looks like. Okay, let's just check what I have here. Okay. I have a lot of questions now, like why it requires the storage account. The serialization is a simple one because it happens on a different process, and we cannot just pass a pointer. We need to encode our stuff, send it there, decode, process. Why it doesn't allow async calls, not clear. Why it complains about non-deterministic behavior. So to understand this, we need to see how durable functions work under the hood. Suppose we have an orchestrator function. When it comes to execution of an activity function, it sends a message to worker items queue, which is created automatically in your storage account. That's why we need a storage account. And then this orchestrator function, it can be unloaded from the memory, and we stop paying for this. And at the same time, activity function gets triggered by this message in the work items queue. And it does the processing, and then it puts the result to control queue, which wakes up the orchestrator function. Then orchestrator function goes further with the process and put another work item message to work item queue, and goes sleep. Activity function processes, control, blah blah. Yes, clear. But the question is, if our orchestrator function constantly got killed and sometimes it is unloaded from the memory, how does it work? Because it needs to restore the state. Because as you remember, we have in the beginning what we do, we load first the image from the storage, then we run first activity function that calculates how many times we can downscale it. and then it it dies, it sleeps. Then activity functions, it returns the execution back. And then how it knows that we already have the results and goes further. So it needs to restore the state somehow. Under the hood, the orchestrator function uses the event sourcing technique, which is called checkpoint replay. Every time orchestrator function calls an activity, it stays checkpointed into history table under your storage account. When activity function is finished, a history is replayed to rebuild the state of orchestrator function. Since orchestrator and activities may be run on different VMs in some environment that is not 100% reliable, this approach gives guarantees reliability actually. And yes, and however, this replay process is reliable, but it leads to some interesting behavior. Let me show on some example with these two funny characters, and just I couldn't find something more mature. Let's practice. Let's let them practice in origami, and ask them to make a plan in a Azure Durable Functions way. So let's say that one of them is orchestrator and another one is activity. That's the reaction, like someone's happy to be orchestrator. And okay, we have this kind of a program. This is orchestrator going to execute this, and all the folding operation going to execute activity. So what happens? Orchestrator encounters the first folding action and calls activity to perform this step. And activity agrees, orchestrator goes to sleep, then activity finishes this task, returns the results to orchestrator via the message in the queue. Then orchestrator wakes up and replies the history to restore the state. So it looks like it asks an activity to perform this first step again. And then, since we already have done this, results are captured, activity is not called. The orchestrator moves further forward with the execution and asks activity to perform the second step. Activity agrees, orchestrator kind of sleeps, then activity finishes with results, gives it back to orchestrator wakes up and says, okay, let's do it again, let's perform the first step. Activity says, no, it's done. And then, okay, then perform the second step. And it's also already done. Results are captured, activity says it's done. Then orchestrator asks to do the first step. Activity is kind of agrees, doing the first step, finish it. Orchestrator wakes up, start from the beginning. Let's build the first step. That is done, and it can go just like continuously. It's like the house that Jack built, and realizing the fact that the state is always replied in this way is very important to avoid some stupid performance issues. If you wonder how it affects performance, let me convert this example into with this 6 chained fault actions into code. So we could have this kind of activities called 6 times with fault. So what do you think? How many times this method will be called? Any idea? Not actually the execution will happen, but how many times we will this exactly that's the arithmetic progression. So it's like 21 times for only loop with the 6 iterations. So this is the plot that shows how this increases. And this is fine when we have this kind of code, but it becomes, the performance started to suck when we see this kind of code. So we do something heavy and then we call the activity. So it means that activity actually will be called exactly the 6 times, but this heavy operation will be called 21 times. And that's why we should perform every heavy processing inside the activity functions. So, but now we probably can answer the question why it was not deterministic. Because if we look back into to my code, we can see that we load the image from the container, from the blob storage, and we scale it down, and we store it. So basically, this scaling down will happen not that amount of times that we calculated for levels, but it will be calculated way more times. And also the cropping will happen probably the first time, but next time it will go here. The cropping is not needed because the image already cropped here. Yeah, so there are some constraints to use the durable functions. Since it will be replied multiple times, it shouldn't it should produce the same result each time. No direct calls to get date, time, generate random numbers, random goods, or call to remote endpoints. And another one, the asynchronous calls. Durable task framework execute orchestrator code on a single thread. And that's why it cannot interact with other threads. That's why we had these issues with asynchronous call. And since all the history of executions is saved into a table and it restores constantly the state, if we have infinite loop, it will end up in out of memory exceptions. So to recap, state is checkpointed in storage table, is replied multiple times, no heavy code should be in orchestrator function, and orchestrator should be deterministic. That's basically what I wanted to share with you. That's all. If you have any questions, welcome.
I have a question about pricing in comparison with usual Azure functions.
It's the same. It's the same function because once it hits the first activity function, it's not active anymore because the state is already saved and it's unloaded. Nobody uses it. So this durable functions can run for weeks. So you can just run a function that will await for some external event, like incoming email, for example, and it will stay dormant for that time.
For example, for your picture that you have one at the beginning,
Yep.
three in the middle, one at
Yes.
the right.
Yep. Yep.
So will we pay for 6 executions?
For this one.
Yes.
So orchestrator function will execute. Yes, it. Yeah, it will be like short executions because it will just restore the state, hit next activity function, trigger it, and goes.
So we will pay for 5 plus each
Oh,
time
that's what you mean. Yes,
and plus orchestrator.
orchestrator, of course. Yes, yes,
executes
yes,
Each time when
Yes.
it's executed.
yes,
So some overhead.
yes. Some overhead. Yes.
Okay.
How is it with the image that you loaded? Is that then stored? Like, let's say this is a 10 gigabytes image or something like that. Where is that stored?
Image which I load. Yeah, it's Azure Blob Storage.
So, but the function is loading that into the function, right?
Mm-hmm.
And then when it
Oh, you mean when we call the activity where this image is stored?
yeah.
So it's also stored in the. It goes with the message, or it's stored also in some internal structure that Durable Function framework builds for you in your storage account. So it's there. Yes. Yes. It's if you take a look into what into your storage, what you had. Suppose it was clean and nice, and then you start using Durable Functions, and you see some crap appearing. You, so you have to do it. Azure doesn't do it for you.
But the thing is, like in this orchestrated function, you shouldn't do any I/O operations at all, because you can end up with this, like you'll hit the limits of this, like you're saying, like 10 gigabytes file adopted.
Yep.
Underlying storage will support that.
Yep.
You'll have another performance issues.
Mm-hmm.
So basically, in that case, we'll just rather like offload this load of image into another activity functions and store pointer somewhere.
Mm-hmm.
So it will be deterministic, right?
Yes, it's in the end how it should be done properly, because this was just to show the all possible. CVs. Yeah.
And I have a question about external storage. You said that when you crop image,
Mm-hmm.
when state will be restored, it
Mm-hmm.
won't be will be the same state because image wouldn't be cropped again. I understand correctly.
Yes. Yes.
So if we
Yeah, we
say
can.
that, state will be restored in nature, it can be different state.
Oh, what I meant is that we crop the image and we save it with the same name, so kind of in the same blob storage. And next time when it's the state is replayed, you read the same image, but it's already cropped. You could save it under the different name, but then still, like it's probably the way how it should be done, because then another time it gets replied, you read original image which is not cropped, and it will crop it again and save it again. So you should just think about it, about all these possible situations. More questions?
Yeah, just have a simple question. So if you had to solve this problem again, would you still utilize?
No, of course not. No. It's definitely not for image processing tasks, because you have this basically the most overhead you have, which you don't want to have, is you need to serialize the data, pass it, deserialize, process, and it's huge overhead. It's better to, if you want to do image processing, just run it in Docker container.
And maybe you could name a few appropriate ways to use durable functions.
Yeah, there are many nice use cases for like business needs, like when you need to react to some external events, or to when you have some difficult complicated pipelines, when this happened and I want this happen. It's basically the same what you have in AWS with step functions, but with step functions you have each function separately with a code, and then to see the whole workflow you go somewhere to some dashboard, look at it. But yeah, in Azure they solve it differently. You have everything together in one solution, like just in the code. You don't. If you go to Azure portal, you don't see how does it work.
This is process loading.
Yeah, Yes, yes. That's the proper use case. Yeah.
Could you restart the function when you're just removing the storage?
Remove the storage and
Restart the function, like just from the beginning?
what do you mean?
Like if you have this run, maybe like you're on image function, and then all of a sudden you remove the storage, then it would start from the beginning again, I guess.
If you remove all this data where the state was stored, of course, yes, it will. And the same, if your process was broken somewhere in between, then next time you run it, or in debug mode, for example, it will still try to restore the state, but you sometimes you need to go to the storage and clean the history table. And if you don't clean the history table and play with the same process all the time, it gets so huge that at some point you see that something happens with my performance. It's like I even asked on Twitter this. I wrote something like the Azure's durable functions sucks because the performance is unpredictable, and they immediately jumped in and started to answer how to do it and blah blah blah. It's a really nice way to approach them. Yes. Yeah? No questions? Thank you very much.